So hello, it's me Yumashi Limbu, and I'm gonna present about mechanical changes for overarm throw. So then we're gonna start with introduction first. So starting with mechanical changes task, that's overarm throw, pretty much what I mentioned, and then mechanical outcome of interest would be the release velocity of the throw. So the suggested mechanical change would be trunk further away in a wind up position. So that would mean a downward movement of the throwing hand and arms, and also the hips and shoulders are rotated to a point where the non-throwing side faces the target, just as shown in the picture on the right side. You can see pretty much see the object doing all of those as I mentioned. Now we're gonna go to our next slide. That would be video tracker. So while recording a video, there were certain things we should be careful of, and those things are lighting, field of view, parallel or perspective error, shutter speed, frame rate, and focus. So in order to overcome, or we try to avoid it as much as you can. So starting with lighting, it was pretty simple because we recorded during the daylight, so there was no any other external or artificial lights that were present, so it wouldn't really affect the video quality. And the field of view was, I placed a tripod in a fixed position with my phone so that there wouldn't be any perspective error as well, because we also made the subject stand in a marker in the middle of the field of view so that he wouldn't move, because we're recording two videos and we wouldn't want him to be in two different positions while recording two different videos. So with shutter speed, high shutter speed was used of around 1 by 4000 as the ball is moving in a faster motion, and frame rate was pretty much high because we were supposed to track later on a slow-mo video, so that we wouldn't really want anything to be blurred. And the focus was just on the subject, so everything else would be clear as well, but the main focus would be on the subject. So also with the calculations, we pretty much calibrated the calibration stick, and it was 0.52 meters, and then the clip settings were just as normal as it can be. Now moving on to our next slide, that would be results. So firstly, we started with our participant who took part in two trials where he was supposed to perform two different overarm throws. So the first one would be a simple overarm throw but without winding up his arms, and the second one would be by winding up his arms. So the key major outcomes differences between two trials can be seen, and it's pretty significant as well. Like in the first graph you can see the velocity is actually decreasing to a point, and the point is minus 1.264 meter per second, and then it started increasing. That's when you release the ball, so the release velocity would be 1 - 1.264 meter per second. The value is minus because we're in a linear motion, so it's a movement in a straight line. So in context of linear motion, an initial velocity can be negative when the object is moving in a opposite direction of chosen positive direction or reference frame. So the video was pretty much in a linear motion, and then the hand is going moving forward or backwards. And before launching, he actually moved his hands a bit backwards. That's the reason his velocity is negative. The release velocity is negative. And with the second one, we can see that the velocity is increasing. So you can see the main difference is in 1.5 seconds when his velocity started increasing. That's when he winded up his arms, and then before releasing you can see the velocity is up to 2.513 meter per second, which is a huge difference. And then when you release the ball, it started decreasing. So even though the velocity is decreasing here, it's still much higher than the first one. So that's what we're comparing and looking at the moment. And with the figures as well, you can see the position he started with. The first one was pretty bad because he didn't really do anything with his trunk, and the second one was a very long wind up. So we'll move to our biomechanical concepts now. So starting with biomechanical concepts, the first one would be Newton's second law of motion. So everyone pretty much know what Newton's second law of motion is. So it's pretty much a force upon an object which causes it to accelerate according to the formula F is equal to ma. That's force is equals to mass times acceleration. So the acceleration of the object is directly proportional to the force and inversely proportional to the mass. That's what we should be careful of, because the mass in this presentation is same, because we're using the same subject, but the thing we're focused on is the acceleration. Because when he started with a very stiff position, his acceleration of his arms wasn't much. But when he started, as you can see in the picture on the right, top top right as well, the red one is when he started, and it was pretty stiff. You can see the trial as well. It's pretty stiff, and then when he released it, the acceleration isn't much. But in the second one, he started from further behind when he winded up his arms. That's when you see the whole trial. Yeah, that's how his acceleration was higher. So since the acceleration and force is directly proportional, that means the force increases as well. And the thing is, as force increases, acceleration increases, and velocity increases as well. As acceleration increased, which means velocity also increases, as acceleration is directly proportional to change in velocity. Yeah, now with our second concept, that is angular kinematics. So angular kinematics refers to a branch of biomechanics that focuses on the study of angular motion. It involves the analyzing movement of objects or body segments in terms of angles. So here the we're talking about our joint angle. So in this case, that would be the shoulder and elbow, because that's what from where we're producing our force, and the axis of rotation is pretty much our elbow as well. So this can influence the trajectory and alignment of the throwing arm. So that would lead to further distance traveled by the ball. So if an object rotates to a greater angle of rotation in a given time, it has a greater angular speed. Because as you can see in the first and second video, that's the same thing, because he had a greater angle of his arms before releasing when he winded up. Because of that, the angle of rotation is high as well, and then the greater angular speed. Now the third concept would be sequential sequencing. So sequential sequencing was impacted by this performance because greater momentum was transferred to the body, starting from the leg, then to the rotation of trunk, and continued to transfer to the participant's elbow extension, and finally to small muscles of the forearm. And that's when you release, and then all of his force gets transferred, and all the momentum get transferred to the ball, which helped to produce a greater velocity, which impacted the release of velocity. As you know, momentum is mass times velocity, and as we know, mass is constant here, and since velocity increases, momentum increases as well. And by properly sequencing the activation and coordination of body segments, the sequential um, segmental approach aims to maximize the transfer of energy, enhance force generation, and improve movement efficiency. That's how more force more force is transferred to the ball, and since more force is transferred, the ball travels more faster because the ball is traveling in a higher acceleration. So that's pretty much the end of our presentation. Thank you.